Hello dear friends, welcome to BYJU'S Exam Prep and I welcome all for this session which is Mathematics Special Series, and in today's class we talk about conditional probability. And before actually starting with conditional probability, I start with some problems based on this counting and probability. Then we start with the idea of today, that is conditional probability. So let us start with some. Hi Tushar, very good evening sir. Welcome to the class, welcome to the session. Okay, so first let us solve some problems based on this counting and probability, which are very important for GATE point of view. And similar questions were asked in GATE many times, my dear friend. And before that, okay, this is the topic of today, and this is about me, myself, Sridhar Sir. I am having teaching experience and my qualifications are given here. I am associated with BYJU'S from past 1.5 years, and we were working on this particular project called GATE video lectures. We created visualized animated content for you, my dear friends, and under BYJU'S Exam Prep app, know this particular category, learn with video lesson. There you can find the videos or the subject videos which were recorded by me, which are like engineering mathematics, discrete mathematics, algorithms. Hi Sujata Labate, welcome to the class. Very warm welcome to one and all. So first let us start with the first problem. A box contains 4 red and 3 black balls. 4 balls are removed from the box one by one without replacement. What is the probability of selecting 3 red and 1 black ball? Hi Naveen, please answer this question. Please try this problem, sir. First one. This is one of the important variant which was asked in, or which is asked very regularly in GATE examination. BSc exam students are not eligible for GATE. Okay, you have to complete your MSc, my dear friends. Then you are eligible for GATE. Okay, BSc are eligible for some different some special GATE categories, but they are not like technical sessions, like you cannot get into MTech, CS and other things. Okay, please note that. Yeah. Please answer this question, sir. Wonderful question, and one of the important variant for GATE point of view. One of the important variant for GATE point of view. You can find similar type of questions asked in GATE many times, my dear friends. Please answer this question. A box contains 4 red and 3 black balls. So in the box we are having, so suppose this is your box. In the box we are having 4 red and 3 black balls. This is a situation. Hi Lalit Yadav, very good evening. Warm welcome to sir. Warm welcome. Now please tell me, what is the probability of selecting? Means 4 balls are removed or selected, whatever you can say, one after the other without replacement. What is the probability of selecting 3 red balls and 1 black ball? Please write your answer, sir. Please write your answer for this problem. One of the important question, similar type of question you can find in GATE, almost 15 plus questions. Almost 15 plus questions you can find of the same format in GATE examinations. See. Okay. See, my dear friend, whenever this type of problem asked, like you are having 2 categories and you are making a selection, and suppose they say you are selecting one after the other, and you want, suppose you selected say K of them, and out of that K some are taken from this and some are taken from this, one after the other without replacement. For all those problems the answer is the same. The probability of this event you can easily write like this. Total, how many you are selecting, sir? Total, how many you are selecting? 4 out of 7. So without any condition, 4 out of 7. Without any condition, it is simply 7C4. Now what is that you want? You want 3 red and 1 black ball. 3 red can be selected from 4 red in 4C3 ways, and 1 black can be selected from 3 black in 3C1 ways, my dear friends. Am I clear? And if you simplify this, you get the answer 4 into 3 divided by 7 into 6 into 5 divided by 3 into 2 into 1. So that is nothing but 12 upon 35. And it is one of the important variant for gate point of view, my dear friends. One of the important variant for gate point of view. Please remember, this type of problems are very common, my dear friends. This type of problems are very common. So you are having one category, two categories. You are having two category, category A and category B. Okay, suppose you are having 10 of this, 5 of this, and you are selecting 3, one after the other without replacement. 3 or 4 or whatever it is. Suppose you select a number of selected. Number selected is say 6, let us say. You selected 6, one after the other without replacement. What is the probability that you get, okay, 4 of them and 2 of them? For all such problems, even though it is selected one after the other without replacement, under probability this value will be simply, under probability total 15 you are selecting how many, sir? 6, and 4 are coming from A part and 2 are coming from B part. See, if the order is not mentioned, see in this problem what is very important is the order is not mentioned. 3 red and 1 black ball. Suppose if he says first 3 red balls selected, then 1 black ball selected, you can't do it. If the order is not mentioned, remember, if the order is not mentioned, then directly you can do it, sir. Suppose if the order is mentioned, then you can't do it. So let us see that in the next problem. When you can't do this, let us try to understand in the next problem. So whenever they say 6 are selected one after the other without replacement, what is the probability of selecting 4 of A category, 2 of B category? If he says, directly this is the answer for this. Directly this is the answer. If the order is not mentioned, if the order is not mentioned, he never said first 3 red, next 1 black, nothing like that, then you can use this procedure. Suppose, look at this problem, it was a very recent gate question. Very recent gate question, last year gate question only. What about the answer for this problem, sir? What about the answer for this problem? What about answer for this problem? Please answer this. See, today what all problems I am going to solve, they are all gate variants only. I am going to solve all the gate variants only. See, generally people worry about, how much we need to do, what we need to do. See, in gate, for probability point of view, especially when you are going for engineering mathematics part, there is some restriction which you understand, then you can solve any question which they ask in gate, my dear friends, very easily. Am I clear? You should know the restriction properly. Otherwise, you will be solving problem for your lifetime. Probability can never be completed. In the first session, I told you why probability is difficult. And you can make that difficult also. A simple topic, learn how to make it simple. Try this. Waiting for your solution, sir. What is the answer? Not finding right option. Not finding right option. 15 into 60, 15 by 60, very good. Vishwanath Murali, very good, sir, very good. A is the correct answer. See here, the difference between previous problem and this problem. Can you tell, Murali, what is the difference between previous problem and this problem? What is the difference between previous problem and this problem? Can you tell me the difference between previous problem and this problem? Those who understand can play with these topics, sir. Because this type of questions they are asking in GATE regularly. And you are ready for that. What is the difference between previous and this one? If you observe in this particular problem, he mentioned the order. First ball is blue and the second ball is black. Here the order is mentioned. Here the order is mentioned. Here order is mentioned. See, these are the two variants, sir. Yes, Lalit, very good. These are the two variants. Those who understand can handle the problems very easily, sir. These are the two variants. Not visible. Which one is not visible? Order is not mentioned. First selected ball is blue and second selected ball is black. Is it due to color of black? It's not visible. Now let us see this. See, total we are having 15 balls. In the box what we are having? 15 blue balls and 45 black balls. You selected 2 balls randomly without replacement. Means one after the other you selected balls, my dear friends, without replacement. What is the probability that an outcome in which first ball is blue and second ball is black? So what is probability that first blue and next black is selected? See here, when they mention the order, the favorable situation here would be, okay, what is the favorable situation? First you want blue and next you want black. Now you please tell me, in this bag or box, whatever it is, what is the probability of selecting a blue ball? What is the probability of selecting a blue ball, sir? You can select a blue ball from total, how many are there? 60. How many ways you can select blue ball, sir? 15 ways. Because ball is not replaced, how many balls remaining? 59 balls remaining. One is gone and only 14 blue balls are left. Now what is probability of selecting black ball? What is probability of selecting black ball? Black can be selected in 45 ways. So it is 15 by 60 into 45 by 59, sir. 15 fours and 45 by 59 into 4 is 236. So the right option is option A. It's a very, very simple, straightforward problem, my dear friends. Don't mess up with the problems. They are very simple. Okay. For GATE point of view, they expect you to know some basics. Know it, you can easily answer questions, my dear friends, which were asked in GATE. Okay. The first type of category which I shown, they ask many questions of that type, and this is another variant. When the order is mentioned, this is how we solve it. And don't do it like, don't do it like 6C2, 15 into 15C1, 45C1. Don't do this. This is wrong for this problem. This answer you can do it if the order is not mentioned. If he says that one blue ball and one black ball is selected, then you can do it. If the order is mentioned, you have to solve by this method. If the order is mentioned, you have to solve by this method. Please remember. The next one. So you can have 2 categories or 3 categories. Same story. 2 articles are chosen at random. Find the probability that both are good. See, we are having 10 good articles, 4 articles with minor defect and 2 with major defect. 2 articles are chosen at random. Find the probability that both are good fellows. BSc students, I doubt. Okay, you can connect me in this Telegram channel, sir. I also go through it. Okay, see, according to my knowledge, they are not eligible. If it is eligible, I let you know. Okay, Sujata, you can connect in the Telegram channel. You can ping me separately. Okay. See, 2 are chosen, selected, 2 are selected. See, selected now, when you talk about next selection, then you need to talk about whether you replace it or not. When 2 are selected means 2 are selected. That's it. You are not replacing it. You need to ask about with replacement or without replacement. After this, if you do any selection, then you should ask me. Am I clear? Yeah. So it is direct. Total, how many are there? Total articles would be 10 plus 4 plus 2. That is 16 articles. You are selecting 2. So what is probability that? The both articles selected are good. Both are good. So total would be from 16 you are selecting 2 and the 2 selected must be good. How many good articles are there? 10 are there. 10C2, my dear friends. 10C2. So I can ask you a question. What is the probability that none of them are good? I can also ask you questions like, what is the probability that none of them are good? What is the probability that none of them are good? See, my dear friends, The categories which I am giving are the standard categories. You can check the previous gate questions. Then the next category would be obviously independent dependent events followed by total probability. See, you can identify the problems which were given in last 25, 30, 35 years, whatever you see it. You can easily identify the standard variants which are given. Am I clear? Yeah. So none of them are given. None of them are good means you are actually selecting from this 6 only. You are selecting from 6 only. 6C2. So none of them are good means both are selected from bad ones. That is 6C2 by 16C2, my dear friends. Is the idea clear? Hope you understand. Babu, clear? You made a mistake, now you corrected. Correct. Nice. Solve this problem. There is a very popular question, I just changed it for you so that you can easily answer. For computer science students, this problem is equivalent to probability of selecting one function. That is the question actually. For computer science student, this is probability of selecting one function type of question. Otherwise, you can easily answer this. This is a very popular variant. I just changed the numbers. That's it. Very popular question it is. Okay, some people also remember the numbers. That's why I changed the numbers. Yeah. Answer the question, my dear friends. Please answer the question. Waiting for your answer. Waiting for your answer, my dear friends. Yeah. Where is that? Yeah. कहाँ है answer? कहाँ है answer? 4 people get on an elevator that stops at 6 floors. So we are having an elevator which stops at 6 floors. 1, 2, 3, 4, 5 and 6 floors. Assuming that each has an equal probability of going to any one floor, that is each person. Okay. Find the probability that no 2 passengers leave at the same floor. What is the probability that no 2 passengers leave at the same floor? What is the answer, sir? Very popular question. Please answer this. See, generally, people want to solve many problems. Standard variants, first they don't know how to solve it, but they want to solve all the variants in the world. Yeah, I know that confusion happens. Am I clear? See, this is the problem with most of the people. They solve many things, ignoring the very basic. They'll not ask you very strange questions or very standard variants only they are asking. You see, last 20-25 years questions, I actually categorized. When I written this handbook of mathematics, I just categorized all the problems from each category. And I could able to find all the variants which they are asking regularly. Okay? There is a book called Handbook of Mathematics which was written by me. And together with the formula, what I done is, I just categorize problems. That is the biggest problem for most of the people. They don't even know how to categorize the problem, but they complete mathematics. They don't know when a problem comes, it comes under which category. Right? See, simple, sir. Suppose A, B, C, D are 4 people. Okay? First, I am finding total number of possibilities. The first person is having how many possibilities, sir? Where he can, of course, right now I am not with that organization, but you can find a Handbook of Engineering Mathematics. Okay, you can find the book earlier. Okay. Now, you please tell me where this fellow can go. This A fellow can go to how many places? Join my Telegram channel. I'll give you all the formulae. Okay, regularly. Don't worry, sir. Just join my channel. You'll get all that. Yeah, 6 possibilities. A is having 6 possibilities. A is having 6 possibilities. Given that B is having how many possibilities? Given that B is having how many possibilities? Given that B is having how many possibilities? Come on, sir. Same, na? B also can, see, if I don't put any restriction, B is also having 6 possibilities. C is also having 6 possibilities. D is also having 6 possibilities, which is nothing but 6 power 4. Which is nothing but 6 power 4. Not 5, sir. Lalit Babu, 5 happens if you say that the second person cannot get out where the first person get out. That is the favorable situation. I am not talking about favorable first of all. I am talking about total situations. What you are saying comes under favorable situation. What you say comes under favorable situation. Here I am talking about total number of situations. Okay? So this is actually same as number of functions from set A to set B, which is given by number of elements in B power number of elements in A, which is 6 power 4. As a functions also you can see 6 power 4, my dear friends. So this is total. Now I am talking about favorable number of situation. What is the favorable situation, my dear friends? What is the favorable situation, my dear friends? No two fellows should drop at same floor. No two fellows should drop at the same floor. Suppose first fellow is having 6 choices. Given that second fellow will not have 6 choices, because what you want, they should drop at different floors. So second fellow will have only 5 choices. Second fellow will have only 5 choices. Given that the third fellow will have only 4 choices. Given that the fourth fellow will have only 3 choices. And mathematically, what is this, you know? It is same as number of 1-1 functions from set A to set B. You are talking about 1-1 function. We are talking about 1-1 functions. Very good, Dinesh Teja. Super, sir. 1-1 functions. And number of 1-1 functions is given by the formula BPA. So that is nothing but 6P4. And you all know what is 6P4, no? What is 6P4, sir? 6 factorial by 6 minus 4 factorial. That is 6 factorial by 2 factorial. That is 6 into 5 into 4 into 3. And that is exactly this one. That is exactly this one. That is exactly this one. So now the answer for this problem is, what is the probability that no two passengers leave at same floor? Is nothing but favorable number of cases by total number of cases. What will be the favorable number of cases, sir? Formula wise, if you want to do it, 6P4 by 6 power 4. Formula wise, if you want to do it. But if you want to do it as we already calculated, which is nothing but 6 into 5 into 4 into 3 divided by 6 into 6 into 6 into 6. Simplify, 1 6 is cancelled, and 6 2's and 2 3's, and it is 5 upon 18. So the correct answer for this problem is 5 upon 18. 5 upon 18 is the answer. 5 by 18 means how much, sir? 0.27. What is it? 0.27. Simplified answer I am giving. Use calculators to answer this question. All of you able to follow, sir? This type of problems are having very high probability of occurring in GATE examination. Don't mess up, sir. They'll ask you very standard questions, standard variants. They want to check whether you know standard formulas or not. And for CS people, this is same as, you know, you are having a functions from set A to set B. What is the probability that the selected function is 1-1 function? This problem is same as that. That's what I'm saying now. You are just saying that number of 1 functions. See, the same problem for a computer science student is a function, okay, a function is selected at random from set A to set B, where A is having 4 elements and B is having 6 elements. What is the probability that the function is 1 function? This is same as this question, sir. These two questions are one and the same. If you observe, all these type of questions we are having, say, okay, here we are having say m people and here you are having n or m and n. Okay, we need to arrange these people in these n places. Without any restriction it is n power m. With restriction it is npm. So that is exactly what happened here, my dear friends. Yes, sir. I created the content, okay, taking all possible variants in a very systematic manner, because the content was divided into half an hour each. Okay, my any content, because I prefer doing topic category wise. Okay, I'll check each topic, okay, and I divide the problem category wise, so that whenever you get a new problem, you should understand it comes under which category. So that is my methodology. So obviously, mostly my students say that they can identify the questions. That is the first headache most of the people are having. So once you can do it, mostly you can easily answer the questions. And that is the biggest headache, my dear friends. Most of the people have this particular doubt, like, you know, this problem comes under which category. They don't even know how to categorize problems. Am I clear? So that is one of the important thing which we need to learn. Categorization बहुत important होता है. Categorization सबसे माहिर, बहुत important होता है. If you cannot categorize the problem, how you solve it? So the 3 variants which I given today, they are all gate variants only. I given all the gate variants, and not they are asked once, sir. The first problem which I given, almost you can find around 15 problems of the same type in the gate examination. Am I clear? Right. Now this union and intersection formula, if you know it, that's good. If you do not know, quickly I'll give you. Probability of A union B is given by probability of A plus probability of B minus probability of A intersection B. So this is generally called inclusion-exclusion principle, sir, because when you add A and B, the common portion is added 2 times. That is, it is included 2 times, so we exclude 1 time. So it becomes inclusion and exclusion principle, my dear friends. So probability of A union B is probability of A plus probability of B minus probability of A intersection B. See, generally people see this formula only like this, but I also see the same formula like this. I can also identify what is probability of A intersection B from this. Probability of A plus probability of B minus probability of A union B. See, when you know this formula, you know this formula also. And I generally find that if I ask this question, majority of the people worry about it. ये कहाँ से आया था? यही से same formula I use, nothing there, nothing else. I just use the same formula. Very good, very good. So here I ask probability of A intersection B, which is probability of A plus probability of B minus probability of A union B, which is 4 by 5. I think someone already answered. Very good, sir. 1 by 9, 14 by 45. Which one is correct? 2 different answers I am finding. 2 members given right answer. 1 person given different answer. Simplification is biggest headache, my dear friends. Please be careful. Probability of A intersection B is, simplify this properly. Simple problem. And you know, mostly when such questions, direct questions also, people do mistakes. Somewhere or the other they mess up and they'll get wrong answer. Oh yeah. See, in Byjus we have double advantage. We have dual advantage. You will get both recorded as well as live content. It's not just live content, sir. You also get recorded as well as live content. That is what they might be saying. You misunderstood that. Okay. See, it's not only recorded content are available, sir. So we are providing to the students double advantage. Okay. So that is, and the recorded content is done in a very, very systematic manner. That's what I'm saying. See, live is obviously because, you know, in the recorded what I assume what questions you ask and I answered that. And I just category wise I divided and I solved it. Whereas in live I can clear your doubt, my dear friends. See, that you need to ask the team, my dear friends, because I am not into the marketing or, you know, what do you call that? People who sales team. Okay, so for that I am sorry, I'll just let them know your query. That I can do from my side, but the team, because in BYJU'S, the content team and the what do you call marketing and sales team are completely different, my dear friends. Okay, so that is all, right? Next problem. Now, what about this probability of A complement intersection B complement? See, this is neither A nor B, my dear friend, which is nothing but 1 minus probability of A union B. See, generally that union problem is read as at least one. This is read as what, sir? At least one. Whenever they ask at least one, it is kind of union problem. It is what they are asking. They are asking for union of the events, whatever you are having. At least one event happens. Probability of at least one event happens. So you are finding probability of A union B, my dear friends. Okay, sir. Ankit sir, very, very good. Thank you for your feedback. Your feedback means a lot for me. Am I clear? Because I am with BYJU'S, I am doing live content as well as recorded content. Whatever is required for our team, we are doing all that. It is for you, my dear friends. Okay? Some people like live content, some people like recorded content. We are providing both. Okay? Yeah. Thank you for the feedback, first of all. Neither A nor B is 1 minus probability of A union B, my dear friends. Super, Teja, super, very quick. That is rapid faster. Super. So, which is nothing but 1 by 5. Super cool. Please answer this question. Yesterday I given shortcut trick for this. See, people generally what happens when we are giving quality content even on the YouTube. I am providing the quality content even on the YouTube. I am solving good problems, standard variants, category wise. Okay, you can utilize this also, my dear friends. It's not like, you know, YouTube we need to hide something. There is nothing like that. Any content, anywhere we provide it, okay, as it is required. See, only thing is, in classes what happens, we explore more variations of the same type. Whereas here we'll give that those who can capable of exploring on their own can use this content and you can easily crack, okay, the examination questions, my dear friends. Hi sir. Mutturaj, hi. What is probability that sum is equal to 3 or 4? See, according to A union B formula now, so it is probability that sum is equal to 3 plus sum is equal to 4 and sum is equal to 3 and 4. But here if you observe, 3, the outcomes which give sum 3 and the outcomes which give sum 4 are completely different. So here we say that A intersection B is empty. Then what happens to probability of A union B, sir? It is simply probability of A plus probability of B. So here it becomes simply probability of sum is equal to 3 plus sum is equal to 4. So total is always 36 and sum is equal to 3, how many cases? 2 cases. Sum is equal to 4, how many cases? 3 cases, which is 5 by 36, my dear friends. 5 by 36. What is probability that sum is neither 3 nor 4? What is probability? That's very, very good, sir. You people are rocking, sir. You are solving standard problems very quickly, very easily. What is the answer for this? Sum is neither 3 nor 4. What is the answer for this? Very good. Neither 3 nor 4 is nothing but 1 minus sum is equal to 3 or 4. A complement intersection B complement, which is nothing but just now we solved sum is equal to 3 or 4, which is 5 by 36. So it is 1 minus 5 by 36, yani 31 by 36. 31 by 36. This is one of the important question, my dear friends. What is probability that sum is neither this nor that? This question is one very important. So I'll ask you quickly one more question. What is probability that sum is neither 7 nor 9? Please answer this question quickly. Please answer this question quickly. For you, the problem is on your board. Very good. 1 minus 7 or 9. 7 6 cases, 9 4 cases, 6 plus 4, which is nothing but 1 minus 10 by 36, which is 26 by 36, my dear friends. Super. Okay, I'll write it here down so that I will not cover your solutions. 26 upon 36. Standard ones. Very, very cool, sir. Super. You are doing very well. Where I kept this? Somewhere I kept it. Okay, fine. No problem. Looking for this. Now we move on to the next important topic, that is conditional probability. I'll explain this with examples. We'll do conditional probability with examples. Conditional probability. What is the answer for this? Yes, 1 by 6, 1 by 6, only 6. Look here, sir. You need to understand this. For example, a failed dice is rolled. What is probability of multiple of 3? What is probability of multiple of 3, sir? I am just asking this question, not asking the question which I asked. I just changed the question. What is probability that we get multiple of 3? Please answer this question. Please answer this question. What is probability that we get multiple of 3? Please answer this question. 1 by 3. Very good. See, multiple of 3 means total 6 outcomes, in which how many are multiple of 3? You know, multiple of 3 means 3 or 6. That is 2 favorable out of 6. 1 by 3 is the answer. See, very good. Very good, Murali, and very good, Lalit. Very good, Dinesh. Everyone is talking. Good. But when you actually say multiple of 3, the meaning is multiple of 3 when the sample space happened. Actually, this question, when we ask any probability of any event, the question is probability of the event when the sample space is happened. So sample space means 6 outcomes happened. In that, how many are favorable for multiple of 3? 2 are favorable. This is regular probability. See, probability of any event can be written as probability of the event when sample space happened. Probability of the event when the sample space happened. But here you are interested in probability of multiple of 3. Is it sample space? Is it sample space? Is number greater than 5 is sample space? Is it sample space? No. So what is happened is not sample space. It is not sample space. It is not sample space. What is happened is number greater than 5 happened. Shivananda, see carefully. Number greater than 5 happened. That is, what is happened is only 5, 6. This is happened. When this happened, what is the cases which are favorable for multiple of 3? That is, out of these 2. So, number greater than or equal to 5 means only 2 outcomes happened, not 6. Only 2 outcomes happened, 5, 6. Out of this, How many are favorable for multiple of 3? Only 1 is favorable for multiple of 3. So the answer is 1 by 2, not 1 by 6, sir. Answer is 1 by 2, not 1 by 6. Is the idea clear? And this is the main mistake which most of the people, and this is the point which most of the people misunderstand with conditional probability, my dear friends. So the answer is 1 by 2, not 1 by 6. Those who understood can send me a like. Right? Super. Got it? That is the story, sir. That is the story you need to understand. Here, that is the story. And this is the biggest misunderstanding which most of the people do it. And you know the same example I give always. Okay, I have been doing it from the last 20 years, and every year I find at least 50 to 60% people giving the answer 1 by 6 for this. Okay, so that is the heights of misunderstanding of this conditional probability, my dear friends. It is not mistake, that is misunderstanding. Okay, so if you can come out of it, conditional probability is a Lilliput game. Now please answer this question correctly. Please answer this question 100% correct. By 4. Yeah, now what is happened? See, this is called what is happened. What happened? Multiple of 3 is what is happened. Multiple of 3 is what is happened. You know multiple of 3 means? When a failed die is rolled, multiple of 3 means what? 3 is 6. That is, what is happened is only 3, 6. No, Gali, that is also wrong. Yes, Shivananda, you are rocking, sir. Super, Shiva, super. Murali, super. Murali, super. Lalit, super. Wow, wow. That's it. Nothing more than that. See, this is what is happened. In that, how many are favorable for number greater than 2? See, number greater than 2 means 3, 4, 5, 6. But sample space not happened. This is what happened. In that number greater than 2, how many? Both are numbers greater than 2. 2 by 2, so the answer is 1. 2 by 2, the answer is 1. Are you able to follow? See, conditional probability. This is what we call it as conditional probability, sir. We write probability of A given B. How you read it? Probability of A when B has already happened. See, this is the meaning of conditional probability, sir. A given B means probability of A when B has already occurred, happened. Then you are finding it. Probability of A given B means that. Probability of A given B means probability of A when B has already occurred or happened. That is conditional probability. That is conditional probability. So we read it like probability of A given B. How you read it? We read it as probability of A given B, or we read it like probability of A when B, like this. These are the different ways we read it, sir. And that is about conditional probability, my dear friends. That is about conditional probability, my dear friends, and the topic of today. Please answer this question. This was GATE question. You see this? Worth 2 marks. Please answer this question, sir. Waiting for your answer. My dear friends, a failed coin is tossed 3 times in succession. If the first toss produces a head, then probability of getting exactly 2 heads in 3 tosses is what? Three by 4 according to Vasu. Vijay Sai says 1 by 2. Wow, Vijay, you are rocking. Superb. Dinesh Teja says 3 by 8. So most of the people misread the question. They read it from here itself. I always tell my students, don't read the question half the way. Read full question. Lalit also read half the way only. See the question. Coin is tossed 3 times. So first let us forget about all this. Let me write the complete story. When you toss a coin 3 times, total 8 outcomes will be there. Normally total 8 outcomes will be there. So most of the people are solving with this. Let me tell you. So if you want to list out all those, it's like, start from the last row, last column, write head tail alternatively. Head tail, head tail, head tail, head tail. Now double the number of heads and double the number of tails. 2 heads, 2 tails. 2 heads, 2 tails. Now again double the number of heads and double the number of tails. That is 4 heads and 4 tails. See, normally if you read this problem from here, most of the people say denominator is 8. Exactly 2 heads they read it. So they say exactly 2 heads. 1, 2, 3. 3 by 8. I think most of you might have given an answer like this. But which is a blunder. Because you read the question wrongly. What he says is, if the first toss produces head, what is the probability of getting exactly 2 heads? So the question is like this. What is probability of getting exactly 2 heads when first toss is head? This is the question, sir. This is the question. So when the first toss is head means not 8 possibilities, sir. When the first toss is head, it is not 8 possibilities, my dear friends. See, when he says first toss is head, only 4 favorable cases happened. Only these 4 happened. Only these 4. Snehal Patil, you made a mistake. Most of the people are making the same mistake. They misunderstand conditional probability and they do mistakes. So here the story is, first toss is head means only these 4 cases happened. In that exactly 2 heads, how many cases? Only 2 cases. So the answer is 1 by 2. Few people answered beautifully like John. Very good, sir. You rocked, sir. John rocked wonderfully. Lalit Yadav corrected. Shivananda corrected. It's not okay. If you are going for that, yeah, you can do that. That is, you are going with the formula, sir. Like probability of A given B formula you are going, then it's fine. Am I clear? See, some people they do this by formula like probability of A intersection B by probability of B. This is the formula I give you in a while. Here I am just doing it by observation, not by formula method. Okay? So by formula method, if you want to do it, you can do it. Probability of B will be what? First toss is head means what? What is probability that first toss is head, which is 4 by 8. A and B, first toss head and 2, exactly 2 heads means what? First toss is head and exactly 2 heads means it is also 2 by 8. So which would be 2 by 4, which is 1 by 2. Formula method also you can do it, sir. Babu Murali, 3 by 8. See, Murali, if you want to do by formula method, this is the formula method. This is the formula method. And please, exactly 2 heads. Normally, you are reading the problem from here. You are not reading from here. Read the complete problem. It is called purposive sampling. What you are doing is called as purposive sampling. You see exit polls. In one channel they say only this party is going to win. In other channel you see only this party is going to win. Because they take survey from the people who are favorable to that party, and these people take survey from the people who are favorable to this party. This is called purposive sampling. You read the question. See, in formula it is 2 by 8 by 4 by 8. There is no 3 at all. There is no 3 at all even in the formula. A and B. Because first toss is head and exactly 2 heads. First toss is head and exactly 2 heads. How many cases? 2 only out of 8. Am I clear? First toss is head and exactly 2 heads. Only 2 out of 8 cases. Okay, if you want to use by formula. Got it? Next problem. Please answer this question, sir. Wonderful question. This is also very, very beautiful question. See, generally, I never ask student, to learn everything in the world. But when I am doing a series, I expect at least you see my series, you can answer the questions. I'll frame the questions in such a way that at least with this minimal knowledge, you can answer. And I am solving gate level questions. They are not my personal choice questions, sir. They are all gate questions. And eligible gate candidates. I might be changing the numbers and they are all eligible gate questions. In gate, it is all about logic, not the length and breadth. People who don't understand the logic, they will give you all such nonsensical questions they will discuss. Okay? Super Dinesh Teja, super. Wow, I like it. I love that. Wonderful. A pair of dice is rolled. Find the probability of getting a sum is equal to 5. See the question. Find the probability that you get sum is equal to 5 when it is known that I just call x1 as outcome on first die. Outcome on first die or dice, and x2 as outcome on second dice. Got it? So, what is that you want? This situation you want. 3, 2, 2, 3 divided by 1 plus 2 plus 3 plus 4 plus 5. So you can do different ways. I given yesterday one beautiful technique for you to remember. Whenever 2 dice are rolled, there are 6 cases where x1 equal to x2. And these are the cases where, that is 15 cases where x1 is greater than x2. And there are 15 cases where x1 is less than x2. So here when he says x1 greater than x2 means how many cases happened? 15 cases happened. Very good, sir. Very good. 4 by 15 is wrong answer. 4 by 15 is wrong answer because for sum is equal to 4, sum is equal to 5, 4 favorable cases out of all the possibilities. See, sum is equal to 5. You see 1, 4, 2, 3, 3, 2, 4, 1. These are the 4 cases. This is when you have sample space, but here sample space is not what happened. x1 greater than x2 happened. x1 greater than x2 means only these two are favorable, because x1 greater than x2 means these are not possible. Only 2 out of 15. So 2 by 15 is the answer, sir. 2 by 15 is the answer. 3, 2 and 4, 1 out of 15. 3, 2 and 4, 1 out of 15. See my dear friend, always remember, sum is equal to 5, 4 cases are there. Out of that, 2 will be favorable for x1 less than x2 and 2 will be favorable for x1 greater than x2. That you can remember, sir. Please answer this question. See, when there is a rank less than 100, obviously there is a high probability of getting it. Suppose there are 1000 students. What is the probability that a student selected at random get a number less than? There are 1000 students, okay, and of course 1000 ranks are there. What is the probability that a student selected at random gets rank less than 100? Can you tell me what is the probability? You will understand, Lalit Yadav. You please tell me what is the probability that, suppose 1000 students are there, what is the probability that a student selected at random get rank less than 100? So 100 favorable out of 1000. 1 by 10, 0.1, if 1000 students are there. 100 by 1000, no, according to my problem. So probability wise, that is 0.1 if you are having only 1000, because, okay, generally, why I said 1000 only, because generally getting under 1000 is simple, but making it less than 500 is very difficult. Those who know standard results, standard concepts, standard ideas properly can easily get less than 1000. See, I always tell people, those who don't know the standard results, at least standard result, can never crack this examination. Those who know standard results decently, all the standard results, in every subject there will be some standard concept, standard results. Those who know can easily get up to 1000 ranks. 500 to 1000 it may vary. And those who can apply those concepts, they are going to get rank between 1 to 500. And again 1 to 500, it varies how well you apply. Am I clear? 100 is included. If it is included, if it is excluded, then it is 99 by 1000. If it is included, then this difference. Got it? Yeah, what is the answer for this? Okay, I am having another class, so I need to conclude this quickly. And tomorrow I will be coming up with Bayes theorem, sir. Tomorrow class is very important, sir. Tomorrow class is very, very important. I will be discussing Bayes theorem with example. With example, I create the rule for Bayes theorem, total probability, then we take some problems on that. Tomorrow we will do that. See, my dear friend, here probability of A is 1 means A is sample space. Those who understand this is a Lilliput question. A is the sample space. A is the sample space. Now, when he asks, what is probability of A given B? See, one should also know the formula for A given B. Probability of A given B is given by the formula probability of A intersection B by probability of B, my dear friends. This is a formula. So, what is probability of A given B? Because A is the sample space, intersection B, given probability of B. Because B is subset of sample space, therefore it is probability of B by probability of B, which is nothing but 1. Which is nothing but 1. So probability of A given B is 1. And what about probability of B given A? Because A is sample space, probability of B given A is probability of B given sample space, which is nothing but probability of B, which is nothing but 1 by 2. So the answer is 1 and 1 by 2, my dear friends. So the answer is 1 and 1 by 2, my dear friends. A simple question. Is the idea clear? See, generally I always tell my students, mathematics is never difficult, only we make it difficult. Okay? Mathematics is the most beautiful, easiest subject, and mathematics is difficult only if you misunderstand the concept. So I always suggest my student, it is better to stop learning mathematics if you misunderstand. Okay? If you are misunderstanding, stop it. Then you are safe, mathematics is also safe. If you don't misunderstand, mathematics is the easiest subject in the world. It is the easiest subject in the world. Only difficulty with mathematics I find is misunderstanding. See, here we cannot take it as independent events, sir. We cannot take it as independent events, my dear friends. Okay, that is not, because independent means you have to prove that A given B is equal to A, B given A is equal to B. Okay, but you know probability of A given B is not equal to probability of A, they cannot be independent, my dear friends. Okay, tomorrow's class will be very, very Clear, sir. See, probability of A given B is equal to A, then see it's like this. I'll give you some interesting result. Please look here. See, actually probability of A when B is already happened is equal to probability of A intersection B by probability of B, my dear friends. This is a definition. Actually, this is the definition of conditional probability. Probability of A given B means probability of A intersection B by probability of B. Of course, probability of B should not be equal to 0. Now, when A and B are independent. Now, some people always get this particular doubt. Let me make it clear. Two events A and B are said to be independent. Two events A and B are said to be independent if happening or non-happening of one event does not affect happening or non-happening of other event. See, this is the definition of independent events, my dear friends. This is the definition of independent event, my dear friends. See, probability of S is 1 means what? Probability of any event is 1 means that is sample space only. Probability of S is equal to 1 means that is sample space only. Only that is called sure event. Certain event is sample space. So the event must be sample space. Okay, that is equal to. That is the outcome of the event must be equal to outcomes of the sample space or outcomes of the random experiment. Am I clear? So that's why I take it. Okay, sorry. I was talking about. So, when you say A and B are independent, you know what happens? This is a wonderful result which I am giving. Please remember, tomorrow also we use it. If A and B are independent, probability of A when B has already happened will be same as probability of A, and probability of B when A is already happened is equal to probability of B. That is, happening of A does not affect happening of B, and happening of B does not affect happening of A. And you know, probability of A and B, probability that A and B happened will be simply probability of A into probability of B, my dear friends. This is the interesting result when you know that A and B are independent events. This is the interesting result when you know that A and B are independent events. Shivananda, is that clear? Did I made my point clear to you, Shivananda? You asked the question and I clarified that. Because probability of A is 1 means that is certain event. See, knowing a result, everyone can do it. Okay? We may run a formula series. In that all the formulas will be given. Okay? I can give you all my formula list also. Please do join my Telegram group. Okay? Where I will be sending that formula list in mathematics and other topics also. See, writing formulas is just a starting point, sir. Application of the formula, how you apply them, that matters. Hi, sir. Okay. Yeah. So this idea is very important, sir. When A and B are independent, what happens? Probability of A and B will be probability of A into probability of B. Not only this, sir. When A, B are independent, A complement B also independent. That is, this is also equal to probability of A complement into probability of B. Probability of A and B complement also equal to probability of A into probability of B complement. Not only this, probability of A complement and B complement will be equal to probability of A complement into probability of B complement. See, happening or non-happening does not affect happening or non-happening of the other event. Yeah, given Telegram group is here, sir. CS_Sridhar. CS_Sridhar. So, today I am having another class, sir. We'll continue with this problems tomorrow. Okay, I'll start with this problem, with some problems on this conditional probability, then we move on to the Bayes theorem tomorrow, sir. Okay, so you can try this problem. I'll be sending these notes in the Telegram group, sir. Okay, by today night you will get this in the Telegram group. You will find this notes. What we discussed, you will find that in the Telegram group, sir. Okay. So that's all for today. We'll meet tomorrow at 7 p.m. Tomorrow at 7 p.m. for Bayes theorem. We'll try to understand Bayes theorem, sir, tomorrow in the class. I'll come up with some good example where you understand Bayes theorem completely. Thank you, sir.